All right, now number 5 says, using point A, which is at 1 f of 1, and the general point E, x here is 1 point, or 1 plus h, and the y value is f of 1 plus h. Find the general expression for the slope of AE. Okay, so the slope of segment AE is going to be equal to, well, how do we find slope? You got it, y2 minus y1. Mr. Allen, we got that. We took algebra 1. That's no problem. Okay, so let's go ahead and do that. So what's y2? Well, y2 is this. That's f of 1 plus h minus, what's y1? F of 1 over x2, which is 1 plus h, and then x of 1 is 1. Agreed? All I'm doing is plugging in the stuff that's given to me. Now I'm going to kind of get into my writing there, but that's okay. Let's keep going. So to find f of 1 plus h, and by the way, I think we said that f of t, isn't it like 4t minus t squared or something like that? So now I'm going to plug this 1 plus h into that. So that's going to be 4 times, and I'll do this in a different color, 1 plus h minus 1 plus h squared, that's this part right here, minus f of 1. What was f of 1? 3. I think we said it was 3 earlier, didn't we? Yeah. So that's 3. All divided by, well, what's 1 plus h minus 1? 8. That's just h. Okay, still not quite there, but we're getting there. Now I got to do a little bit of algebra. Okay, so that's going to be 4 plus 4h minus, now I'm going to get 1 plus 2h plus h squared minus 3 all over h. All I did there is I did the distributive property, and then I FOILed that 1 plus h thing squared. Okay, so let's clean that up some more. So we're going to go 4 plus 4h minus 1 minus 2h minus h squared minus 3 all over h. Okay, it's getting better. Still not there yet, but we're getting there. What's 4 minus 1 minus 3? A 0. So that gives us, oh, by the way, what's 4h minus 2h? 2h. So that gives me 2h minus h squared over h. Okay, now I think my scroll bar is over here now. Okay, we can extend it. By the way, are there any common factors of h in the numerator? Well, yeah, there's a factor in each of those, right? So then this is going to become 2 parentheses, oops, not 2. Try that again, Mr. Allen. How about h times 2 minus h over h, which is 2 minus h. This will give me the slope of the secant line AE. So for example, when h, by the way, h is equivalent to the delta t, the change in t. The problem that we did up here, what did we change? We started with a change of 0.1, right? Then we went to 0.01. Then we went to 0.001, right? So if h was 0, in other words, there was no change, what's the answer going to be? Isn't that what we just said? Didn't we just say that right here? It makes good sense, doesn't it? So this is the answer to number 5. Now notice, this problem became a lot more involved than the other ones. And it required me to do some calculation, some algebra, if you will. Okay, some algebra. Any questions on that one? Zoom this, sorry. Okay, so we've got this secant line, and as we get closer, as the h gets closer and closer to 0, it's going to become the tangent line. This tangent line is what we're going to call the instantaneous rate of change, which is different than the average rate of change. In Algebra 1, we asked students, what's the average rate of change? In calculus, I'm going to ask you, what is the instantaneous rate of change? So at any given instance, you can tell me the rate of change or the slope of the tangent line. What is the definition of the slope of a tangent line? Well, it's given to you right here. It says the limit is delta x goes to h of f of c plus delta x minus f of c over delta x. And by the way, if you look in your notes from section 2.1, which is the video for this week and the notes for this week, guess what you'll see for the definition of the slope of a tangent line? It's in this same box. I literally just copied it and pasted it in here. So there's no surprise. This is building on what you've hopefully done before you came to class today. So now the last two questions, these are the two that require some work, okay? So question 7 says, analytically, find this limit. And I'll remind you that in this particular problem, I think that we said f was 4t minus t squared. So let's see how you did, okay? Let's see how you did. So I got to do the limit as h goes to 0. By the way, h is the same thing as delta x if you're confused. How many of you prefer delta x? Anybody prefer? Okay, great. Who prefers h? Go with it. I don't care. They're both the same. They're both equivalent. The only thing I want to warn you of, don't use as x goes to 0 or something like that. That would have a different meaning, okay? We'll see an example of that here in just a second. So we're going to do the limit of, now I'm going to do f of, so in other words, this f of 1 plus h, that's going to be 4 times 1 plus h minus 1 plus h squared. That's what f of 1 plus h is. This is, remember composition of functions back in Algebra 2? I'm doing a composition of functions. And then I got a minus f of 1. Well, what was f of 1? I think we said that was 3. And then I'm going to divide that by h, so I'll just go back to green. We'll just call this h. So here's the limit we got to deal with. Now, guess what happens if we do direct substitution here? Guess what we're going to get? 0 over 0. In fact, every derivative problem, which is what we're talking about, you just don't know it yet, every derivative problem will end up with an answer of 0 over 0. So that's not going to work. So we have to do something a little bit more specific. In other words, we need to do some algebra, and that's what we're going to do here. So we're going to say the limit as h goes to 0. And now I'm just going to distribute. So this is going to be 4 plus 4h minus 1 minus 2h minus h squared minus 3 all over h. All I did, now, guys, I did some algebra in my head there, and that's okay. You had a big head start. You can figure that out. Make sure your signs are okay. Now notice what happens to this 4, this negative 1, and that negative 3. Cancel each other out, don't they? 4 minus 1 is 3. 3 minus 3 is a 0. Okay, so then this is going to become, and I'm kind of running out of room here, but I'm going to go ahead and show all my work anyways. I'm going to kind of put a little line around this guy in blue. So that's a separate problem, okay? I'll deal with that one separately. I'm still kind of working on this guy now. So this is going to be the limit as h goes to 0 of 4h. Oh, wait, what's 4h minus 2h? Yeah, I should have just made that 2h. Let's do that too. A little bit more. Oh, boy. Oh, well. Limit h goes to 0, that's an h, of 2h minus h squared over h. Boy, it seems like we're doing the same thing over and over again, doesn't it? That's because that's the way all of these problems do. They all do the same thing. Do I have any common factors of h? Clearly I do. I could factor out an h and an h, canceling the h in the denominator. So that's going to give me the limit as h goes to 0 of 2 minus h, which is what? Huh. That's what we thought it was going to be, wasn't it? That's what we predicted it to be when we were looking at it using the numeric method. When we were looking at the numbers, it was 1.9 to 1.99 to 1.99. And it became 2. In fact, if you look down here when we did remember this was the secant line expression, Guess what happens when you plug 0 in for that h? You get 2. Isn't that interesting? Okay. Now I'm just curious. How many of you were able to successfully get through that? Okay, some of you were. Here's one of the things I've noticed with calculus students, and no offense, they're actually okay with the calculus. Guess what they struggle with? Algebra stuff. Okay. All right, so let's go ahead and finish this guy off. And then we'll talk about something else. Okay, now, what mathematicians like to do is they like to generalize. So let me explain. You see all this work right here? How many tangent line slopes did I find? I found 1 tangent line slope. So what if I said, I'm sorry, I screwed up. I didn't want to know the tangent line when t is equal to, what was the number here, 1? This, by the way, let me write this down. This is the slope. You should probably have this. This is the slope of the tangent line at t equals 1. That's what that is. Or in the application we're talking about, we're saying that the instantaneous rate of change is 2 gallons per hour at, what was it, 10 a.m.? That'd be for this particular problem, right? So geometrically, it's the slope of 2 when t is 1. In this application, it's the instantaneous rate of change. In other words, water's flowing into the tank. How fast? At this instant, at 10 a.m., it's exactly 2 gallons per hour. If you pick any other time t, it's going to be something different. Does that make sense? Okay. What if I said, oops, my bad. I didn't want you to do it for t equals 1. I want you to do it t equals 3. Wouldn't you be kind of ticked off at me? Maybe like, Mr. Brown, you're a big old jerk. I just did all that work and you're making me redo it again. What if there was a way that I could have done something like this, but found the derivative or the slope of the tangent line anywhere? That would have been maybe even more useful, don't you think? So let's do that here. So I'm going to do that with this last problem here. Here's problem number 8. This is the last one. I'll do it in purple. So it says to generalize for any time t, let f of, okay, we already know that's f of t. And then it says find this limit here. So I'm going to do the limit as h goes to 0 of f of t plus h. So guess what I have to plug in for t? T plus h. That's what it says right there, doesn't it? F of t plus h. So I'm going to plug t plus h in there. So 4 times t plus h minus t plus h squared. Let's do a different color. Minus. What do I have to minus? F of t. What's f of t? 4t, I'll do it in parentheses, 4t minus t squared. All of that divided by what? H. So this is the limit that we have to find for this one. Let's go ahead and work it out here. And if you guys don't mind, I'm going to go ahead and just do this one, okay? So this is going to be the limit as h goes to 0 of distributive property, right? 4t plus 4h, that's the distributive property. Now I've got to square this guy, right? So that's going to be minus, and then that'd be t squared plus 2th plus h squared. And then if you guys don't mind, I'll go ahead and distribute the negative here. I think that'd be minus 4t plus t squared. All of that over h. Boy, isn't that scary looking? Put that over there, please. Okay. Now I got to distribute this negative, right? So this would be the limit as h goes to 0 of 4t plus 4h minus t squared minus 2th minus h squared minus 4t plus t squared. Oh, wow, Mr. Allen, that's a lot. Okay, so let's go ahead and clean this up. Oh, don't forget to divide by h. Does anything cancel? Well, let's see here. Do you see this positive 4t and this negative 4t? Have you noticed stuff always cancels in these problems? Anything else cancel? You see this negative t squared and the positive t squared? Do those cancel? Sure. Okay. So this is going to give us the limit as h goes to 0 of, let's see here. I don't think anything else can be combined here. So that's 4h minus 2th minus h squared all over h. Man, wouldn't it be nice if everything in the numerator had an h?
Yes.
Wouldn't that be nice? Oh, everything in the numerator does have an h. So guess what happens to this h, that h, and one of those h's? They all cancel. So this gives me the limit as h goes to 0 of 4 minus 2t minus h. Agreed? And what's happening to h? It's going to 0, so now I'm going to do a direct substitution, and I'm going to have 4 minus 2t minus 0. Guess what that is? 4 minus 2t. Now, guys, guess what we call that? Well, in this class, we're going to call it f prime of t, also known as the derivative.
Oh my God.
That is the derivative of that function. Now, you might say, okay, Mr. Allen, that's really impressive. Who cares? At time t equals 0, let's plug in 2. When you plug in 2 here, what do you get? 0. So, guess what the slope of the tangent line is at t equals 0, or t equals 2? 0. Oh, wait a minute. Let's go back to that. The problem we originally started with was t equals 1, right?
Yeah.
What do you get when you plug 1 in there?
2.
2. Guess what happens when you plug 3 in there?
-2.
You get -2. So here the slope was 2, and then symmetrically, guess what that slope is? Doesn't that make sense? Isn't that beautiful? Don't you wish you had come up with that idea? And I'll be honest, guys, I'm a math guy. I got my master's degree in math. I would have never come up with this stuff. There's a guy by the name of Isaac Newton and a guy by the name of Gottfried Leibniz. They were given credit for coming up with these ideas in calculus. They are the fathers of calculus, if you will. And that's what we've just done. So let me reiterate what we've done here. This guy right here allowed us to find the slope of the tangent line, or the instantaneous rate of change, at one value. And that value, I think, was 1, right? T equals 1. The beauty of this one that I did here, the more general solution, is guess what I can now do here? You just tell me t and I'll tell you the slope of the tangent line. You give me any value you want. You can tell me pi. Hey, Mr. Allen, what's the slope of the tangent line at pi for that function? Okay, it's 4 minus 2 pi. That's what it is. Literally, exactly that's what it is. And you can calculate it and get an approximate value on your calculator, because as we know, pi can't be given exactly. Okay. Questions on that? By the way, how many of you got both those answers? Okay, a couple of you. What was the hard part of both those problems? The algebra, right? It's working out the squaring and the minus, all those. I mean, look at it. It's impressive, isn't it? Okay, so I need to pause. Let's stop that one.